Hello everyone, I Akshika Chaudhary along with my teammates Aditi Srivastav and Ayush Rai going to present our final year presentation under the supervision of Dr. Rizwan Khan sir, Head of Department of Computer Science and Engineering. Our group ID is 3 and our project title is Appearance Based Recognition using Deep Learning. So let's begin with the problem statement. So our project problem statement is to develop a deep learning model that can recognize appearances of disabled people and decode it into text and then into speech to provide efficient understanding. Aim of our project is to bring human-computer interaction to a regime where interactions with computers will be as natural as an interaction between humans. To develop a deep learning model that can recognize appearances of disabled people and decode it into text to provide efficient understanding, converting of these recognitions into text so that it can easily be interpreted and understood by mute people will provide such people a way to express their thoughts and ideas. So it will be a platform where normal humans can interpret what mute people are trying to convey. Now, the introduction of our project. As gesture has always been a part of our communication since eternity, the goal of this project is to bring the performance of human-machine interaction closely similar to human-human interaction and provide support to disabled persons. The sign language to speech conversion model is developed with OpenCV, Keras, and deep learning and computer vision communication notion with people using American Sign Language ASL based on real-time video broadcasts with motions. The suggested model aims to convert such sign gestures into speech that is understandable to the general public. The entire model pipeline uses CNN architecture to classify 26 alphabets and one additional alphabet for null character. The proposed work has an efficiency rating of 99.93%.
Now, I will be discussing the literature survey of our project. We referenced various papers and summarized their methods and findings. Then we have compared their work on the basis of few parameters. The first parameter is accuracy of the model. Accuracy of S.S. Cathode was 94 percentile. M. Agarwal and S.Chatroj has moderate accuracy, whereas our model showed 99.33 percentile of accuracy, which is highest among all the compared models. The second parameter is dataset. S.S. Cathode and S.Chatroj didn't use self-generated dataset. M. Agarwal used combination of Kaggle and their own dataset, whereas our present study uses 60% data from Kaggle website and Michigan University, and 40% of data is self-generated. The third parameter is model used. Our present study has used CNN sequential model, whereas others have not. The last parameter that we referenced is speech conversion. S.S. Cathode and S.Chatroj didn't converted their text into speech, whereas M. Agarwal and our model has the feature of text-to-speech conversion.
In this work, a deep learning model is evolved to address communication issues between healthy and mute people. For this study, we have used TensorFlow, OpenCV, GTTS, Keras, Model Checkpoint, Matplot Library, NumPy, sklearn, and Placeroute. A brief explanation of each requirement will be explained while we walk through the code. Our model is capable of predicting gestures from American Sign Language in real time with high efficiency. These predicted alphabets are converted to form words and hence form sentences. These sentences are converted into voice modules by incorporating Google Text-to-Speech API. So here we can see that the Gaussian filter is used for a pre-processing technique to make the image smooth and eliminate all the irrelevant noise. Intensity is analyzed and non-maximum suppression is implemented to remove false edges. For better pre-processed image data, double thresholding is implemented to consider only the strong edges in the images. All the weak edges are finally removed and the strong edges are considered for the further phases. So now let's walk through the code. So here we can see the file name called ASL train, which is used for training and saving the model. And here we can see the model saved ASL classifier.h5. Over here we can see the dataset used. The datasets used here consist of 17,113 self-generated images belonging to 27 classes, 26 be it like A to Z, and one extra character for the space or the null. The training set consists 12,485 images, and the test set contains 4,260 images. So let's walk through the real-time implementation. So let's run these snippets. So first of all, here we are importing the necessary modules and the model we have saved. Here we are loading the model, the ASL classifier.h5. Over here we are dictating the dictionaries of 0 to Z. So now the images are here. So let's try the image. So I'm stopping the real-time implementation and let's see what's the result. Yeah, so here we can see EXZ. Now let's import and install the GTTS library to read the text or the sentences that are converted. And since here we are mentioned EN for the English language, we are now working towards converting it into native languages too. So first of all, let's try it into the English language. So yeah, let's play. I hope you can hear it. I'll play it again. So the welcome 2151, the file that we have saved, just reads the converted text EHC. So we can also play it right from a text editor using the play sound. Let's try it again. So yeah.
The source of information of our project is as follows. Our group came across a non-profit organization called Sound of Silence. This is the country's first technology-based NGO. They assist people with the special needs, that is 80% with manpower and rest with the help of technology. No one has time for these things in today's hectic world. Nobody can dedicate 24 hours a day, 7 days a week to them. As an outcome, We must reduce the interaction gap between counselors and abled people. This project will aid in providing a better understanding without the use of humans.
The, the conclusion of our project is as follows. On the validation set, the model achieved 99.93% accuracy and the prescribed model was assessed on a test set where it achieved 99.86% accuracy with a loss of 0.59% after training by TensorFlow GPU 2.0. The study proposed a sign language detector which further gets converted into voice to address communication challenges between healthy and mute people. We concluded that the performance of our model is best and can be used in future for the welfare of mute people. Thank you.